combinations. Definition. Each of the groups are selections that can be made by taking some or all of a number of objects is called a combination. Each of the groups are selections that can be made by taking some or all of a number of objects is called a combination. Before we have discussed permutation. Permutation means arrangement, whereas combination means either grouping or selection. Now, example. Consider 4 objects A, B, C, D. Now, list all possible groups. List all possible groups. Number 1, 2 at a time, 3 at a time, without any repetition. Two at a time. AB, AC, AD, BC, BD, and CD. That means only 6 are possible. Whereas in permutation, AB and BA are possible, but whereas in combination, only AB. So in permutation, order is important, whereas in combination, order is not important. Whether you write AB or BA, it will be same in case of combination, whereas AB and BA are different in case of permutation. Next, take in 3 at a time. ABC, ABD, ACD, BCD. That means only there are 4 possibilities. Number of combinations of n distinct objects. Number of combinations of n distinct objects taken or at a time is denoted by N, C, R. One more notation. One more notation. So these are the different notations. So in this, the first one notation and the last notation are important. You should remember. And it is defined as NCR equal to n factorial upon r factorial into n minus r factorial, where 0 less than or equal to r less than or equal to n. proof. That is, number of combinations of n distinct objects taken r at a time is denoted by NCR, and that you can prove it as NCR equal to n factorial upon r factorial into n minus r factorial. Now, let us assume that there are x combinations are possible. Let us assume that there are x combinations, means x groups or x selections are possible. Now, if I consider one combination contains r objects, one combination contain r objects, and those r objects can be arranged among themselves in r factorial ways. One combination contain r objects, and r objects can be arranged among themselves in r factorial ways. For x combinations, so the number of arrangements will be possible is x into r factorial, which is same as number of arrangements of n distinct objects taken r at a time, which is npr, which implies x equal to npr upon r factorial, or n factorial upon r factorial into n minus r factorial. That is NCR equal to n factorial upon r factorial into n minus r factorial. In terms of factors, it can be written as n into n minus 1, n minus 2, and so on, n minus r plus 1 into n minus r factorial. N minus r factorial gets cancelled. Denominator is r factorial. So in the numerical problems, when you want to calculate NCR value, either you can use n factorial upon r factorial into n minus r factorial, or use n into n minus 1, n minus 2, and so on, n minus r plus 1 upon r factorial. That is starting with n, reducing by 1 continuously in the numerator r factor upon r factorial. So examples are 5c2 using factorial method, 5 factorial upon 2 factorial into 5 minus 2, 3 factorial. When you simplify, you will get 10. Now in terms of factors, starting with a 5, 2 reducing by 1, 2 factors in the numerator, that is 5 into 4 upon 2 factorial, which is 10. 10c3, starting with the 10, reducing by 1, 3 factors in the numerator, 10 into 9 into 8 upon 3 factors, that is 3 into 2 into 1, which is 120. In the same manner, 10c7, starting with the 10, 7 factors by reducing 1 upon 7 factors, which is simplified, it will be same as 120. So 10c3 is same as 10c7. nc not equal to 1, nc n is also 1, nc1 equal to n, which is same as nc n minus 1, nc2 equal to n into n minus 1 by 2 factorial, which is equal to nc n minus 2, nc3 equal to n into n minus 1, n minus 2 upon 3 factorial, which is same as nc n minus 3. So you can conclude that NCR will be same as NC n minus R. If NCR equal to NCS, then either R equal to S or R plus S equal to N. Using the previous property, NCS we can write as NC n minus S. That means N minus S equal to R. So R plus S equal to N. Next, another important property, NCR upon n minus 1 CR minus 1 equal to n by R. So this you can prove it as use the factorials and simplify. Then you will get n by R. Now cross multiply. So NCR equal to n by R into n minus 1 CR minus 1. That means you can split NCR. Here you reduce it 1, here you reduce 1. That means n by r into n minus 1 C r minus 1. And this can be extended further. Again, n minus 1 upon r minus 1 into n minus 2 C r minus 2 and so on. Next property, NCR minus 1 plus NCR equal to n plus 1 CR. So take left hand side. N factorial upon r minus 1 factorial into n minus r plus 1 factorial plus n factorial upon r factorial into n minus r factorial. Now, in these two, take common. In the numerator, n factorial is common. Among r factorial, r minus 1 factorial, the smaller one is r minus 1 factorial. So take r minus 1 factorial common. Among these two, n minus r factorial is the smaller one. So take n minus r factorial common. So the remaining is 1 upon n minus r plus 1, and here it is 1 upon r. Now simplify and then rewrite in the form of C notation, that is n plus 1 CR. Now theoretically also we can have an explanation for this. Now the right side n plus 1 CR corresponds to number of ways of selecting R objects from n plus 1 distinct objects. That is right side is number of ways of selecting R objects from n plus 1 objects. That we are splitting into two parts. Now these two parts corresponds to one portion corresponds to one object always included in each selection. So one object is always included in each selection. That means one object we have fixed. In the remaining objects, it will be n, and we need to select r minus 1. That's why it is nc r minus 1. So one object always included, and NCR corresponds to one specific object which you have included before. Now here one specific object always excluded. That means the total selections of right hand side can be splitted into two parts by choosing one specific object always included and one specific object is always excluded, because here we have excluded one specific object. So, and again we need to select R only from n. So that's why it is NCR. So NCR plus NCR minus 1 is n plus 1 CR. So NCR upon NCR minus 1 is n minus r plus 1 upon r. So this you can prove it as use factorial notation and then simplify. Then you will get n minus r plus 1 upon r. Next 2n Cn is 1 into 3 into 5 into 7 upon and so on 2n minus 1 into 2 power n upon n factorial. So take left hand side, 2n factorial upon n factorial. 2n factorial means product of first 2n natural numbers upon n factorial into n factorial. Now group all the odd factors and even factors. In each even factor 2 you will get common. So it will be 2 to the power of n into 1 into 2 into 3 and so on, which is same as n factorial. So n factorial gets cancelled. Then you will get the right hand side. So playing cards are 52, which are divided into two parts. One is black and red. Black contain 26 cards and red also contain 26 cards. And again black is subdivided into two parts, 13 and 13, 13 spade cards and 13 club cards. And red also divided into two parts, 13 diamond cards and 13 heart cards. Now in each group 13, one is ace will be there, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, and jack, queen and king. These three are called face cards. (47) C4 plus sigma j equal to 1 to 5, 52 minus j C3. So expand the sigma and regroup the terms and apply the property of NCR minus 1 plus NCR equal to n plus 1 CR. So the expansion is 47 C4 plus 51 C3 plus 50 C3, 49 C3 plus 48 C3 plus 47 C3. So by grouping 47 C4 plus 47 C3, it is in the form of NCR minus 1 plus NCR is N plus 1 CR. That is 48C4. Now 48C4 and 48C3 group it. Then 49C4. Again group with 49C3. Then it will be 50C4. Group with 50C3. Then it will be 51C4. Again group with 51C3. Then it will be 52C4. So prove that the product of R consecutive positive integers is divisible by R factorial. So starting with N, R consecutive. So N into N plus 1, N plus 2, N plus 3, and so on, N plus R minus 1. So this we have to prove that it is divisible by R factorial, means we should have common factor as R factorial into some integer we have to express. So R factorial multiply and divide. And this if we want to convert into the factorial notation, so these are all increasing by 1. So that means before this factors you write, that is 1, 2, 3 and so on N minus 1 upon 1, 2, 3 and so on N minus 1. Now this entire numerator product will become N plus R minus 1 factorial upon R factorial into N minus 1 factorial, which is same as N plus R minus 1 CR, which is always an integer. That means R factor into some integer. Hence the product of R consecutive positive integer is always divisible by R factorial. A question paper has 2 parts, A and B. Each part contains 10 questions. And how many ways you can choose? 8 questions from part A and 5 questions from part B. That is 8 questions from part A. You can choose in the manner as 10C 8. And 5 questions from part B. 10C 5. And it is a simultaneous. Means 10C 8 into 10C 5 ways we can choose 8 questions from part A and 5 questions from part B. So 4 cards has to be chosen from 52 playing cards. First bit. 4 cards are of the same suit. So 4 suits will be there. So one method is from the first suit 13C4 or second suit or third suit or fourth suit, which is same as 4 into 13C4. Or another way of expression is selection of one suit first, 4C1. After selection of one suit, 4 cards from that selected, means 13C4. 4 cards belong to 4 different suits, means 1 card from each. So 13C1, 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 13C1. That is 13 to the power of 4. 4 cards are face cards. So there will be 12 face cards, and in that you have to choose 4. So 12C4. 2 are red and 2 are black cards. So 26 cards are red. You have to choose 2. So 26C2. And 26 black cards are there. You have to choose 2. That is 26C2. So 26C2 into 26C2. So a box contains 5 red balls and 6 white balls. You have to choose 6 balls such that at least 2 balls of each color. That means you list all possible cases such that 2 balls of each color has to be there, and calculate the combinations and then add all the possible cases. So there are 3 cases are possible. So if I choose 2 red balls and 4 white balls, so the number of ways of selection is 5C2 into 6C4. Second case, 3 red and 3 white. So 5C3 into 6C3. Third case, 4 red and 2 white. So number of ways of selections is 5C4 into 6C2. Because these are the different cases, you have to add all this and simplify. So the value will be 425.